Hello there. I'd like to welcome you to the Chapter 6 review for Docere and for my class. And boy, am I going pretty wild on this one. Okay, I guess this is about sedimentary rocks. So we'll quiz you here in Docere with about 15 questions. And here we go. Let's see how you do. So question number 1, I'm drawing a particular structure that is common in this area below the ground surface. And there's another structure which is common, not necessarily in this area, but it's a black layer that you could find in some places. So what's happening with this first stuff is that it's coming out of the ground and they're pulling it out of the ground here around Houston area. But I guess the first question I have to ask is, what is that black rock that they're going to mine out of the ground for energy? And of course the answer is coal. What is this liquid stuff down below the earth that they're pulling out also for energy to make gasoline? Well, this is oil. And then way deep down inside the earth, it could be the source rock where all this good, wonderful energy sources come from. So this, what they'll do with this is that they'll put an interesting horizontal pipe inside the earth, and they'll frack that source rock through hydraulic fracturing. And that is natural gas. And the reason why I start off the Chapter 6 review in Docere with this stuff is because these are forms of energy that sedimentary rocks give us. So now we're going to get into some humdrum type of stuff. So I've taken you to the continent of Australia, and here we have some beaches on the east side, which is loaded with sand. So you are to answer yes or no to the following questions. Has this sand been deposited on the beach? Well, yeah, because it's sitting there. Is the sand unconsolidated? Well, what does that mean? Well, is the sand loose? Yes, likely, but I mean, you really don't know unless you're in there frolicking in it. Has the sand undergone compaction or is undergoing compaction? And the answer is yes, because you walk on it and people drive their little dune buggies on top of it. Is the sand undergoing lithification? Or is it attempting to be lithified? And I would have to answer yes to that. It hasn't completely undergone lithification, because if it did, it would be all glued together. And the final question is the sand undergoing diagenesis? And the answer is yes, but if I were to ask the question, has diagenesis completely finished on this sand, then the answer is no. So now let's take you through the different steps of diagenesis. So this is in pictorial form. So what is the first step of diagenesis when things are squeezed? That is compaction. Okay, if you compact sediment, of course it gets thinner, and the water is driven off through the step called dewatering. Third step, we're going to grow some, from small crystals, we're going to grow even bigger crystals, because there's a little bit of heat and pressure involved, especially down below. So that step is called recrystallization. And then finally, maybe millions of years into the future, when the sediment and sand and whatever else has been sitting around for a long time, then a nice, wonderful geologist will examine that sample, and they will determine that it has undergone diagenesis and probably has determined that it's been glued together. But glued together by what? So the three natural cements are silica or quartz, iron or hematite, and calcium, which is in the form of calcite. So the big million-dollar question becomes, has a sandstone completely gone through the steps of diagenesis? Well, we'll see that. Yeah, diagenesis. And the answer is, it depends, but if it's well lithified, then yes. If it's well put together. Has it undergone lithification? And again, the general answer is yes. You're assuming that it has, if it's well put together. Has the sandstone gone through weathering, completely weathering? And the answer is, well, no, because if the sandstone were completely weathered, you would be holding nothing in your hands. But it is currently undergoing weathering. So here's question number 3. Let's go through the categories of sedimentary rocks. So here is the little box for you, and this is the first category that starts with a C. That's clastic. Next is the middle one that you're learning in lab, which is chemical, and then the B one is biochemical. So can you describe a clastic sedimentary rock? Well, it is one that's made of pieces of other rocks glued together. What about chemical sedimentary rocks? How are they formed? Well, they form when seawater basically evaporates out, leaving the crystals behind. And biochemical forms of sedimentary rocks? They're made of the remains of plants or animals. So now I've got a nice picture for you in question number 4. And the question that I'm asking is several questions. You are to describe the picture in terms of its rounding characteristics. Are the particles in this picture round? The answer is yes, and of course the agent of rounding is water. What is the sorting characteristics, and what are my sorting choices? So of course you have well sorted and poorly sorted with some things in between. What about grain size? Now this one's a little bit tricky because you have big things and you have little things. So is it predominantly sand? Is it predominantly boulders? Of course it's kind of hard to tell without a frame of reference for scale. But the safe bet to say in this one is that it's gravel. Okay, kind of the opposite spectrum picture here. Let's go through this one. What about sorting characteristics? Well sorted or poorly sorted? And rounding? And does it appear that this sand is lithified? And the answer is no. So this is a well sorted, probably a quartz sand that is not lithified. So between this picture and the picture you saw previously, which sample are you more likely to find at the beach? Which sample are you more likely to find at the beach? And the answer is this one, because it's well sorted. So here's question number 5. Let's go through now the sizes of the clastics, or the sizes of the particles or sediment. So it starts with a B, and it's really big. That's a boulder. Next is a C, cobble. And then what gets stuck in your shoe, pebble. There's your freebie. Small now with an S is silt, and clay is even smaller. So now we've gone through the sediment samples, sizes. Which 3 are considered gravel? That's boulders and cobbles and pebbles. And of the remaining 3, which 2 are in mud? And that's silt and clay. So now we have another picture that's kind of the friend to a previous picture. Let's talk about grain size in this one. Is it gravel, sand, or mud? Probably gravel is a safe bet. What about rounding characteristics? Are these particles well rounded or very angular? And they are angular. Okay, what about sorting? Well sorted or poorly sorted? They are poorly. What if I told you that that is a cryptocrystalline or microcrystalline variety of quartz, which starts with the letter C? And you would guess right if you said chert. So this is a poorly sorted angular gravel chunked rock, clastic, and its name is breccia. Okay, has the particles in this rock traveled far from their source area, or not very far at all? Question number 7, we have a nice sandstone. What mineral in this sandstone is going to predominate? What mineral is predominant in that sandstone? And if you guessed the Q, you're absolutely correct. So now I'm going to take you to the east coast of North America, or to the USA. And pretty much all the sand that you're going to find on almost every beach is predominantly quartz. except if you were to travel to Miami or southern Florida, starting around the Fort Lauderdale area. If you go all the way down there, then all the sand is really whiter than normal, and it's loaded with CaCO3. So what is CaCO3? And that's why they call them white sand beaches, because they're made out of calcite. So between the two types that we just discussed, between quartz or calcite, which sand type means siliciclastic? This is a fancy new word I'm introducing in this dossier review. So between quartz and calcite, which one could mean siliciclastic? And that is quartz, because silica is silica, quartz, and clastic means pieces. So all the beach sand, North Carolina, South Carolina, parts of Texas, but not southern Florida, is all siliciclastic. It's predominantly quartz. All this sand laying around, is it lithified? Nope. Is it unconsolidated? Yes. Has it completely gone through diagenesis? No. Is it siliciclastic? Yes. And by the way, with diagenesis, there's chemical changes that could be involved, biological changes that could be involved, and physical changes that can also affect the nature of the sediment. So I misspoke earlier when I said that this one was a cousin to the one previous. I guess I forgot that this one was coming next. So the previous one was breccia. So is this one conglomerate or breccia? And that's kind of a no-brainer. He's conglomerate. So now let's get into a little discussion of limestone. So limestone forms one of two ways. It forms with this O word, organically, or with the I-N-O word, that's inorganically. So let's name some organic forms of limestone, also known as biochemical. So here's the first clue. This guy has got an organic limestone, and he's smearing the little critters all over the board. So that, of course, is a piece of chalk. Chalk is a form of limestone. What form of organic limestone is made of broken seashells that are glued together? And that is the oatmeal rock, also known as coquina. Now we're going to get into a few of the inorganic forms of limestone, inorganic limestone types. So here's the first one. This might amuse you. You and some friends are deep inside the earth like Jules Verne, and you're looking for some beautiful things. Maybe not bats, because bats are coming towards you and they're about to rip your face off maybe. But what form of limestone is hanging from the ceiling? Well, there's a variety of different answers for that. In your lab box, you have chemical limestone, which it really is what it is. But if it's in the form of a broken carrot, then it could be a stalactite or a stalagmite. So which one is this one? Is that a stalactite or a stalagmite? And a stalactite will hold tight to the ceiling, whereas a stalagmite might make it up someday. Question number 11 out of 15. So this is my feeble attempt at drawing a swamp, such as you find in southern Florida in the Everglades. So if all that decaying organic matter is dying and falling to the bottom of the swamp floor, it will compact to form a brown colored rock which starts with the letter P. And that's peat. So peat will further compact through compression of the earth layers to form the first form of coal, which is called soft coal, or also starts with an L. And that's lignite. Lignite will further compact to form a very black colored rock and very shiny and layered, which is called a bituminous. And then if it completely goes metamorphic, it could turn into the ANT coal, which is anthracite. So now we're going to have this picture to consider with question number 12. What are the three categories for depositional environment? The three broad categories. So the first broad categories include glaciers, alluvial fans, so forth. And that's continental. Next is in between the land and the ocean. This starts with a T. Transitional. And then out here is the water, or the ocean, or marine. So what I'm going to do is that I'm going to write a few words, and you are to name the category that it belongs to. And your choices are continental, transitional, or marine. Okay, here we go. The first one, beach. That is transitional. What about a lake? Continental. Alluvial fan. He's continental because he's found on the land. What about a delta? That's transitional. Lagoon. Also transitional. This is partitioned into either shallow or deep, and that's marine. And here's the last one, a tidal flat is transitional. Question number 13, these are layers obviously, but these layers of sedimentary rock, am I showing them as planar or cross beds here? Okay, these are planar beds, and these are cross beds. Question number 14, I have a rock sample, but it's got some funny wave-looking things at the top of it, which seem to be very symmetrical. So any clue as to what they're called? Well, those are ripple marks, and that is one of the many forms or types of sedimentary structure, just like bedding planes and strata and ripple marks. Graded beds I may have mentioned in class. So ripple marks indicate a shallow marine environment. So here is the last question for this review. We have coal, oil, and natural gas. And these are the big three which are clumped under a big umbrella of what form of energy? And the answer is these are fossil fuels. So this will conclude the Chapter 6 study guide on dosiri.